Hello everyone. Today we are going to analyze this fixed beam. In this beam we have two loads. One point load 12 kN in the center, and then we have uniformly distributed load 4 kN per meter. It is acting for the whole span. The length of the beam is 6 meter. To find the fixed end moments in the points A and B, we are going to use formulas. If the fixed beam is subjected to uniformly distributed load for the whole span, the formulas to find the fixed end moments are WL square upon 12 and WL square upon 12. If the fixed beam is subjected to a point load in the center, the formulas to find the fixed end moments are WL upon 8 and WL upon 8. In both of the cases, we have symmetrical loading. That is why in both of the ends, we have the same formulas. The moments in the point A will be acting in the anti-clockwise direction, but the moments in the point B will be acting in the clockwise direction. Now, using these formulas, let us find the moments MA and MP. First, let us take the point load 12 kN. We have just seen the formulas to find the fixed end moments WL upon 8 and WL upon 8. Here W is 12 and L is 6. Now let us take the uniformly distributed load 4. We have seen the formulas WL square upon 12 and WL square upon 12. Here W is 4 and L is 6. After adding these two, we will get 21, and after adding these two, we will get 21. In this beam, we have symmetrical loading. That is why for both of the movements, we have got the same value, but MA will be acting in the anti-clockwise direction and MB will be acting in the clockwise direction. Now we are going to find the vertical reactions RA and RB. We know that in this beam the loading is symmetrical, so we can easily find the vertical reactions. For finding the vertical reactions, we have to divide the total load by 2. There are two loads, the point load 12 and the uniformly distributed load 4. With the uniformly distributed load, we have to multiply the distance 6. Finally, for RA and RB, we are getting 18 kN. Now we are going to draw the shear force diagram. I'm going to find the shear force values from the point A and towards the point B. In this case, I am moving towards right hand side. Upwards will be positive and downwards will be negative. Here you can see the calculations. Here you can see the shear force diagram. Now we are going to draw the bending moment diagram. We know that the bending moment diagram can be done in two ways. The easiest method is superposition method. In this method, first we have to consider the fixed beam as a simply supported beam. You can see that I have converted the fixed beam into a simply supported beam. Let us find the reactions RA and RB. We know that in this beam we have symmetrical loading. So to find the reactions, we have to divide the total load by 2. Initially, we have already done that. For RA and RB, we have got 18 kN. Now let us find the bending moment in the point C, that is the center. I am going to find it from the point A. In this case, we are moving towards right hand side. Clockwise will be positive and anti-clockwise will be negative. RA is acting in the clockwise direction, so that it will be positive and the distance is 3. The UDL is acting in the anti-clockwise direction, so that it will be negative. For the UDL, we have to multiply with the distance and distance by 2. Finally, we are getting 36 kilonewton meter. Then we can draw the bending moment diagram for the simply supported beam. We know that in the case of a simply supported beam, in the ends, the bending moment will be 0. In the point C, we have found the bending moment 36. Since we have uniformly distributed load for the whole span, the bending moment diagram should be in the shape of parabola. This diagram is called the free movement diagram. Then we have to draw the end moment diagram. For MA and MB, we have got 21. Since both of them are having the same value, we will have a rectangle shaped diagram. MA was acting in the anti-clockwise direction and MB was acting in the clockwise direction. Now we have to see the directions of the arrows. Both of the arrows indicate upwards. So the end moment diagram comes above the line. If the end moment diagram comes above the line, that will be negative. If it comes below the line, that will be positive. Right now it comes above the line, so that it will be negative. Now we can combine the end moment diagram and the free movement diagram. Wherever they are alone, we have to mark the values with the signs. Wherever they are together, we should not mark anything, just to keep the space empty. To find the maximum positive bending moment, we can subtract 21 by 36. 36 minus 21, we will get 15. Alternatively, we can draw the bending moment diagram by calculating the bending moment in all of the points. You can follow any one of the method, whichever is easier. In this beam, we have symmetrical loading, so we can easily draw the diagram. We have to find the bending moments in all of the points A, C, and B. To find the moments in the points A and C, we can use right hand side rule. Clockwise will be positive and anti-clockwise will be negative. In the point A, we have the moment MA, which is acting in the anti-clockwise direction, so that it will be negative. Let us find the bending moment in the point C. MA is acting in the anti-clockwise direction, so that it is negative. RA is acting in the clockwise direction, so that it will be positive and the distance is 3. The UDL is acting in the anti-clockwise direction, so that it will be negative. For the UDL, we have to multiply with the distance and distance by 2. Finally, for the bending moment in the point C, we are getting 15 kilonewton meter. To find the bending moment in the point B, we can use left hand side rule. Clockwise will be negative and anti-clockwise will be positive. In the point B, MB is acting in the clockwise direction, so that it will be negative. Here you can see the bending moment diagram. In these 2 points, the bending moment becomes 0. We can find the location of these 2 points, but it is not necessary. Since it is a symmetrical diagram, both of these locations will be same, so we can take any one of them. I am going to take this point and make a section. Let us name the section as XX. We know that in this section the bending moment is 0. Using the right hand side rule, we can find the bending moment. Finally, we will get this equation. Then using the calculator, we can find x, which is 1.377 meter. So we have found both of the locations where the bending moment becomes 0. Now we are going to end this session. Thank you for watching this video.